Szanowni Państwo, witam serdecznie na kolejnym wydarzeniu na Copernicus Festival. Witam także tych z Państwa, którzy oglądają nas zdalnie. Cóż, no zachęcam wszystkich Państwa do siadania. Kwestia techniczna, może od niej zacznijmy. Wykład i późniejsza rozmowa będą się odbywały w języku angielskim. To są ostatnie słowa, które usłyszycie po polsku przez najbliższe 2 godziny. Zachęcam do korzystania z zestawów słuchawkowych. Gdyby były jakieś problemy z nimi, z tyłu jest ekipa techniczna zajmująca się tym, że moje słowa są i będą tłumaczone na język polski. Dla tych z Państwa, którzy nie chcą słuchać w oryginale, gość oczywiście będzie również wykładał w języku angielskim. Jeszcze po polsku wytłumaczę, że jesteśmy na kolejnym dniu festiwalu Copernicus. Jak wszystkie pozostałe jej wydarzenia, nie byłoby to możliwe bez partnerów Centrum Kopernika. Partnerami tego wydarzenia są Małopolska Organizacja Turystyczna i miasto Kraków. Dziękujemy serdecznie. I od tego momentu przerzucam się już na język angielski. So for those of you that don't speak Polish and have been wondering, this is the moment where we begin speaking in English. Welcome and nice to see you. The lecture will be by Professor Thomas Plummer, and the title is Stone, Tools and Human Origins. So the stage is yours, and thank you for coming.
Thank you very much. I'd like to thank the organizers of the Copernicus Festival for inviting me to speak here. It's been really a pleasure to be in Krakow. My family came with me. They've really enjoyed it, and we're already talking about coming back to visit some more. So thank you, and I've really enjoyed being here. Today I'm going to talk about stone tools and human origins. And specifically, when I'm talking about stone tools, there are lots of stone tools. I'm going to talk about a specific kind of stone tool, the oldest widespread technology found in the world. It's called the Oldowan. So I'm going to talk about the Oldowan, the importance of the Oldowan, and its impact on us here today. Humans are primates, all right? And you may look at chimpanzees, you may see chimpanzees in the Warsaw Zoo, and you'd think, oh, wow, I can't believe I evolved from a chimp, because a lot of people say that. Well, you didn't evolve from a chimp, right? You share about 98% of your DNA with chimpanzees, but chimpanzees are not your ancestors. All right, chimpanzees are our closest living relatives, right? But you had closer relatives that are only known from the fossil record, and I'll be talking about some of those today. Chimpanzees are about half the size of humans, or a chimpanzee would be less than half my weight, and their brains are about 1/3 of our size. All right, even though they're very smart primates, their brains are smaller than ours. Their face juts out relative to our face. So this difference in body, and they walk on 4 limbs, whereas we walk bipedally. Even though they're our closest living relatives, we share so much of our DNA sequence with them, they look pretty different from us. Also, humans have very short guts, right? If you think about your gastrointestinal tract, you think about your intestines. Our intestines are actually really short compared to non-human primates. And you might be able to guess the reason why. It's because humans eat very nutrient-dense foods relative to non-human primates, plus we cook, right? So nutrient-dense foods are foods that give you a lot of calories, a lot of protein, amino acids, a lot of micronutrients, metals, whatever you need. Foods that give them to you in quantity relative to their volume. And cooking just adds to the nutrition that we can extract from our food. Cooking makes food more digestible. It breaks down secondary compounds in things like potatoes and other tubers that, if you ate the potato skins raw, you would get sick after a while. You cook them and you can eat them, at watching your sporting events. So cooking is really, really important. And in fact, our gut is adapted for a nutritionally dense cooked diet. If you tried to eat the food that a chimpanzee ate, you would lose a lot of weight very quickly because you wouldn't be able to extract the nutrition you needed from the raw vegetables, the raw fruit and leaves, nuts that they're eating. Humans also share food more readily than other animals. other primates, and most other animals as well. So food sharing is a really important part of humanity, lifeways, of our sociality. And people always say, if you want to get to know someone, you need to break bread with them, right? Food sharing is really, really important, and it's ingrained in our psychology. And food sharing is what makes our reproductive output so much higher than what you see in the great apes. So because we have a high-quality diet and we share food, we can wean our kids at a young age onto food. They're not dependent on their mother's milk anymore, and after a short amount of time, mom can have another kid. So human females can actually have a much higher reproductive output because of weaning and high-quality food and food sharing than the living apes have. And what I'm going to really focus on today is that humans are a technologically dependent species. And this doesn't really occur to people because your whole life is surrounded by technology. But we are a technologically dependent species. And when you go watch shows like Naked and Afraid, this really brings home the fact that when humans don't have technology, they're kind of screwed. So they're not doing very well. And if you drop a couple of people like you do in this show into some wild place, for them to survive, they actually have to develop technology. They have to develop simple gathering technology and hunting technology. They have to make fire. And after that, some clothing, depending on how hot it is or cold it is. So after that, they may do okay and finish the program. But you see that humans, in fact, can't get by just on their own without some sort of technology. All right? And this is not just industrialized humans. Pre-industrial humans lived in the most extreme environments of hot and cold, right? And with high tech, we're able to visit environments that humans were never adapted for, like the deep sea or outer space. So technology is a really, really key part of the human adaptation. Other primates have technology. We are not unique in having technology. Other animals have technology. Some very smart birds have technology. Some porpoises use tools underwater. Right? Having technology is not something that is unique to humans. But when you look at our closest living relatives, the chimpanzees, the technology they use for nut cracking or fishing for termites, that's what that little guy's doing with that stick. He's getting social insects to bite his stick, and then he's eating the social insects. This is not something that they're going to have to depend on for their survival. Most of the diet of chimpanzees and most non-human primates, they gather without technology. So fruits and leaves that chimpanzees are using, they don't need tech to get that. All right? So there's something very different in their use of technology relative to our dependence on technology. Now, I'm going to use terms during this talk. MA means millions of years ago. So whenever you see, and I just don't like typing it out. It takes too much time. So whenever you see MA, it's millions of years ago. And this is just to show you, again, the idea that chimpanzees are our closest living relative, but they're not our ancestor. The last time we had shared a common ancestor with chimpanzees was 6 or 7 million years ago. Chimpanzees have had a separate evolutionary history for the same amount of time that we've had our separate evolutionary history, 6 or 7 million years. And you see this term hominin, all right? It sounds kind of like human. Hominins are all of the creatures that are more closely related to us than they are to chimpanzees. These are our ancestors, our close relatives, right? So when I use the term hominin, I'm basically talking about a human ancestor or relative. And what you can see when you look at this line, this doesn't have all of the species or all of the fossils. There are now thousands of fossils related to human evolution. All right, what you see here is just some of them. And you can see also that there's never a time before Homo sapiens where there weren't more than one hominin around. All right? It's very, very unusual for there just to be one hominin species. It's now, in fact, this is the only time that there's been one hominin species. And if you can go back in time 35,000 years, you would find in Poland another hominin species, right? Maybe Homo sapiens, but also Neanderthals. right? If you go to the Museum of Archaeology here in Krakow, you'll see a little diorama that's got some Neanderthals in it. All right, and Neanderthals were a different kind of hominin, closely related to us, but most people think they're a different species. All right, so the fact that we're alone here on the planet is very unusual for the whole 6-7 million years that our lineage has been around. All right, so here is an early form of hominin, a very famous one because of this fossil called Lucy that perhaps you've heard of. And it's called Australopithecus afarensis. And, I'm showing it with the chimpanzee, with the human as well. You can see that Australopithecus afarensis is the same body size, essentially, as a chimpanzee. Its brain is also about the same as a chimpanzee's. It's considerably smaller than humans. Its face juts out like a chimpanzee, but its pelvis, its thigh bones, its feet are very human-like. It's adapted for bipedality. And what we see, one of the earliest stages in hominin evolution, is you see something that looks in some ways like an ape, but it's bipedal. It's a bipedal ape. And if Australopithecus afarensis was alive today, it wouldn't be, sitting in the audience listening to me or shaking your hand. It most likely would be in the zoo next to the chimpanzees. All right, so this is sort of an evolutionary tree for humanity. And we just talked about Australopithecus. The genus Australopithecus were small-bodied, relatively small-bodied on average. They had relatively small brains, big faces. They're walking bipedally. Also, they've got elongated legs like we do, but they also have long arms like an ape. Paranthropus is another form of early hominin. It's got a body that's similar in a lot of ways to Australopithecus, but it's got enormous jaws and teeth. All right, it's got molars that are 4 times the size of your molars, the biggest molars of any primate that's ever lived. And then you've got the genus Homo. And the early forms of genus Homo really don't look that much different than Australopithecus or Paranthropus. They've got slightly larger brains, but in terms of their build and their body size, they're not that different. Then starting at about 2 million years ago, you see some shifts in the fossil record. You start seeing isolated long bones that are from a bigger kind of hominin. And ultimately, you start finding fossils of something called Homo erectus. The oldest bits and pieces of Homo erectus probably go back to 2 million years, but this very nice skeleton is about 1.5 million years old. And Homo erectus is the first creature that's really starting to look like us, the first hominin that's really starting to look like us. It's got a bigger brain size than Australopithecus. It's twice the size of Australopithecus. Still not as big as ours, but twice as big as Australopithecus. And it's got a body size that overlaps with ours. So there would have been 6 foot tall Australopithecus, also short ones, but definitely large ones as well. And its body plan is much more like ours. So its limb proportions, it's got an elongated lower limb, and its upper limb, its arm, is shortened relative to the apes. This is the first thing that's starting to really look human-like, and this is appearing about 2 million years ago. Oldowan tools, the tools technology I'm going to talk about, span from about 2.9 million years ago to about 1.7 million years ago. And you can see they cross a lot of branches of this tree. It's overlapping temporally with many different kinds of hominins. In fact, it may be that more than one kind of hominin, in fact, I think it's almost certain that more than one kind of hominin used this technology. All right? But I think, this technology is actually key for understanding this increase in body size and an increase in brain size that you see in Homo erectus. And that'll be part of the thesis that I talk about today. The oldest part of the human story is in Africa. All right? It seems like the oldest part of human evolution, about 6 million years ago to 2 million years ago, is a largely African story. And if we didn't have sediments that actually preserved fossils and artifacts, we would know nothing of the fossil record. Right? We're lucky because in Eastern Africa, you have the East African Rift, which has an eastern branch and a western branch. You can see these lakes inside the Rift Valley, right? So that the earth is being torn apart in some of these depositional lows. You've got lakes and streams and rivers. They deposit sediment. You know, early hominins needed to go to water to drink and to the trees around the lakes to have shade. And when they died, their bones would be covered by silt from the waters, from the lakes, and they were preserved. So we're very, very lucky that you had actually a sedimentary trap to have a record of human evolution. If this sedimentary trap didn't exist in Eastern Africa, we'd have far fewer fossils. In Southern Africa, there's another kind of trap for the fossils that preserve the fossils, limestone caves. And these limestone caves were very, very important. And there's a very rich fossil record from South Africa, too. You can see all this blank space in Africa, though. I'm sure there are hominins that lived in many of these places. There's just no sediments. There's nothing preserving them. All right? So we're very lucky that we have these ways of preserving the fossils. After 2 million years ago, humans actually leave, or hominins leave Africa. All right? And you start getting hominins in Asia. You get them all the way into Indonesia. You get them ultimately into Europe. The oldest site that I've seen mention of in Poland is about 500,000 years old. So Krakow is a magnificent city, and you know, it's historical and has a lot of time depth. But the oldest sites in Poland are actually considerably older. All right? And this is older than Neanderthals. This is probably something before Neanderthal, like something that might be called Homo heidelbergensis. So why study the Oldowan? I've been interested in the Oldowan pretty much my whole career. Again, it's between about 2.9 to 1.7 million years ago. It's the first widespread technology. It may represent a major adaptive shift. So an increased reliance at some point during the Oldowan, I think there starts to be an increased reliance on technology for survival. So again, this idea, I've been interested in tool-dependent foraging. Does it exist during the Oldowan? I think during the Oldowan is when you start getting this shift towards foods that actually require tool use to get them, to acquire. There could be a major dietary change going on. We'll talk about that, but it seems like Oldowan tools are being used to acquire all sorts of foods, including large mammal carcasses. And it could be more food sharing is going on starting during the Oldowan as well. What you definitely get are archaeological sites. So you start finding archaeological sites in abundance across the landscape, or relative abundance across the landscape. These are accumulations of bones and stones. All right? They're not generally at places that we think the hominins were living. They're at places we think the hominins were processing food, and they're just leaving their trash behind. And this is broadly associated, like I said, with multiple hominin taxa, and some people would argue changes in the environment too, that's sort of driving these behavioral changes we're seeing with early archaeology. Just until a few years ago, and from when I was a student, you know, the oldest Oldowan sites were known from the Afar Triangle. And the progression across Africa, all of those dots and numbers are actually Oldowan sites. The progression is starting, you know, historically has been known from the Afar Triangle of Ethiopia. So for the longest time, the oldest sites were known at 2.6 million years ago. And then, you know, nothing seemed to happen until about 2.3 million years ago, and it seems like there was an expansion in the Oldowan. You get sites outside of the Afar Triangle. And then ultimately, by 2 to 1.8 million years ago, you've got sites from North Africa all the way to South Africa. And then ultimately, at 1.85 million years ago, at Dmanisi in Georgia. So Georgia is one of the earliest sites that you have stone tools and Homo erectus fossils outside of Africa. Now, the perspective's shifted a little bit just in the last few years. All right, last year I published a paper in Science that was talking about the oldest Oldowan site. It's that site called Nyayanga. We think it's 2.9 million years old. It's on Lake Victoria in southwestern Kenya. You still have these very early sites in the Afar Triangle. You've got sites in South Africa that are 2.2 million years old, and in North Africa, in Algeria, there are sites that are 2.4 million years old. And in China even now, there's a site that's 2.1 million years old. So it looks like the Oldowan, that the archaeology just didn't have this occurrence that appeared 2.6 million years ago and slowly spread. That seems to have been sampling error. It seems like the Oldowan was more widespread earlier on than we recognized. And that may say something about the adaptive significance of lithic technology. So Oldowan technology, what is it? It's a handheld technology. You've got two stones. You hold one stone static, the core, in one hand. It's stable. It's not moved. And then you bring another stone, the hammer stone, down, and you hit it, and you knock off sharp flakes, like John Shea is showing in this little GIF that I've got here. And what does that leave? That leaves cores that have facets. Each one of these facets was where a flake was taken off. These flakes are razor sharp. Right? You can use them just like you would use a Swiss Army knife. So this may seem technologically very simple, but all of a sudden, once you recognize that you can hit two stones together at the right angle and produce sharp flakes, as well as potentially a core with a sharp edge, you can all of a sudden do things in the environment and process things in the environment that you could never do before. And so this is a simple technology, but it's a very powerful technology. And the longer you flake an object, the more facets it has around its edge. All right, and I'm going to talk mostly about the Oldowan sites where I've worked. There are 3 Oldowan localities on this peninsula. I work on the Homa Peninsula in southwestern Kenya. So the very old site I talked about is this site called Nyayanga. I'll talk about that first, and then I'll talk about these 2 younger sites, Kanjera South and Sari River. These are all found, like I said, in between the 2 branches of the Rift Valley on Lake Victoria. And the centerpiece of this peninsula is an extinct volcano called Homa Mountain. And I work with a big group of people. So this is not, I'm giving the talk, but the contributions are widespread. And I'm summarizing a lot of work that I haven't done, that other members of my group have done. So this is a big project. There are, it's completely dependent on all the Kenyan excavators who work with us, who are well-trained and very good at excavating. They can excavate better than I do. If we ever find an important fossil, I just step away and I let one of the better excavators dig it because they're better at it than me. And a wide variety of scientists, both within Kenya and from abroad. So it's an international project with contributions from the United States, the UK, Italy, and a variety of other places. So here's the Homa Peninsula with this, on the satellite image showing it's between the 2 branches of the Rift Valley. And you can see the volcano here and sediments that are outcropping on the flanks of the volcano. So here's the volcano. The volcano looks different in different places as you drive around it. So here's one side of the volcano. You can see the sediments sort of draping on its slopes. Lake Victoria is very beautiful, so there are often boats out in the lake, fishing. There can be very fierce thunderstorms. So when I was a graduate student, I took this picture when I've been working on this peninsula since I was a graduate student. When I was working there, the thunderstorms were so intense that even though we were in army tents, these army tents would get blown down. And I just hated being inside the tent when it blew down. So I'd actually put on my poncho and just go and stand out in the rain and let the rain pelt me, just because I didn't want to be in the tent when the tent was blown down. So there are very fierce thunderstorms periodically. There are outbreaks of lake flies, which don't bite. It's like they don't bite you. They only live for a day. They just live to mate. So in their adult form, they're just coming out, they're flying around, they're trying to find a mate. But they are, like other insects, attracted to lights. So they'll fly into your face, they'll fly in your ears, your nose. They are a bother. But most of the time, it's just really beautiful. The people are very nice. This is a nighttime shot where fishermen are out in the lake attracting little fish with lights and catching them in nets, right? Little minnow-sized fish called omena. And this is some of the sediments. This is what the sediments look like at one of the sites. So as you go around the mountain, you find outcrops of sediments where they've been, This is basically old material that had sloughed off the mountain. In the past, the mountain was much higher, right? This is now just the eroded core of the mountain. It would have been much more magnificent in the past. It's still nice to look at, but these sediments have all eroded off the mountain, and that's what's preserving fossils and artifacts. In fact, in this picture, there are beds that are 4 million years old, as well as beds that are 6 million years old. Now, what's interesting, there's a really cool sort of natural history experiment, something that you would have devised if you could have imagined it, and that's a difference in the properties of the rock from around the peninsula, around this mountain, versus the properties of the rock that are off the peninsula. So the rock that's coming from this carbonatite volcano is soft. It actually doesn't hold an edge very well. So when you make stone tools from it, the edge dulls very quickly. The rocks that are coming from off the peninsula, which are actually washing down in highlands and rivers and streams, and that get diverted because the mountain domed up the landscape, the streams get diverted to the Lake Victoria on either side. These rocks are actually much harder and make much better stone tools. So you get to see, how did the hominins respond to this? Did they actually appreciate differences in raw material quality? And are they actually transporting some of this good rock to the sites, the better rock, the harder rock? Or are the stone tools just, is soft stone just good enough? I'm not making tools that often. Can I just use what's at my feet? Do I need to bother to transport this higher quality rock? So that's one of the things we've been looking at. We actually characterized the rocks from different areas. You can actually source them. You can determine whether your rock has been transported from far away or not. And we've also done mechanical, like physical sciences tests, material sciences tests, to show that the rock from the peninsula, like this limestone, is much softer than the rock that's quantitatively softer than the rock that's coming from off the peninsula, like this quartzite. All right, so now I'm going to talk about the sites in sequence. I'm going to talk about the oldest site first, Nyayanga. This is the Nyayanga Gully. You can see it here. You can see those springs, those freshwater springs marked. Those were actually springs that were available to the hominins. So they would have been providing fresh water to the hominins 2.9 million years ago. All right, the stream itself may not have had water in it all the time, but the springs would have then been a really important local attractant because everybody needs water. There's a gully system that goes downslope towards what is now modern Lake Victoria. The gully system starts fairly low. You can just hop into it. Fossils are eroding out everywhere, though. So here's part of a hippopotamus eroding out as the rains just wash down the gully. As you go down the gully system, though, you can see this amphitheater here. The ravine, it becomes a very big ravine. And in this big ravine, you can see the cross-section of a stream channel. This is actually the filled-in channel that was laying down the deposits 2.9 million years ago. And this is why we've got these ancient stone tools and fossils preserved, because this ancient stream, when it flooded, would bury whatever was alongside it, and the hominins were carrying out behaviors, in the margins of the stream. Right? It would have been a nice place. I mean, there would have been trees there. They could have gotten fruit or nuts. There was shade. The hominids are hanging out there. They're doing their business with their stone tools. They leave, and when the stream floods, the materials get buried, and we have an archaeological site. So I'm going to be showing you some sites on this slope that are the overbank deposits from this ancient stream channel. And of course, 70% of paleoanthropology or paleontology is actually geology. So I've got this geologist, Peter Ditchfield, who's worked with the project for a long time from the University of Oxford. And this is my son, who came out for a few seasons and was working with us. And when we first started here, we were just what you needed to do when you're first working at a place, and this is a place we didn't know before about 2007, is you've got to figure out the geology so you can have definitions for the beds. You can then sort fossils and artifacts to their correct bed, and you can date the beds so that everything is tied together with a pretty ribbon, and you have a good sense of the story of the locality. So Unit B ultimately became Nyayanga Bed 1. Unit C up here ultimately became Nyayanga Bed 2. There are fossils and artifacts in both of these beds, and in fact, there are 2 beds above them that I'm not talking about today that have fossils and artifacts as well. So geology is super important for dating the site and for thinking about how the site was formed, what the depositional environment was of the sites. And just when we were walking across the surface of the sediments, we were finding stone tools. So it's clear that you had the Oldowan here. Here's one of these big facets. Here, a flake had been knocked off of this core. There's another flake knocked off there, another flake knocked off there. Here's one of these stone flakes from a different raw material. Often these still have sharp edges. You could still use them to cut things even when you find them today after almost 3 million years. And there are also pounding tools in Nyayanga, a lot of pounding tools, more than have been found at any Oldowan site. So they're not just cutting things, they're also pounding things quite a bit. And we found the bones and teeth of many, many different animals. Pigs are really our friend. Wild pigs evolve very rapidly. So you can actually say something about the age of your site without using a fancy dating method. You can look at the species of pigs you have and actually get an idea of how old your site is. And I have a pig expert who works with me named Laura Bishop from Liverpool John Moores University in the UK. And you know, she was walking with us in the site and said, wow, these pigs are really old. This has got to be a very old Oldowan site, just from looking at the pigs that were there. But you've got also 3-toed zebra relatives, 3-toed equids, right? Not the 1-toed ones like we have today, like horses. These actually had 3 toes. Lots of antelopes, even more hippos. This place is a hippo paradise. It's like hippo heaven. There are so many hippos. We have hippo fossils everywhere. If you kick a big bone, it's almost certainly from a hippo. But also cool things like saber-toothed cats, giant elephant-like creatures called Dinotherium, enormous crocodiles that could eat you in a couple of bites, lots of different kinds of monkey, and also a hominin. Right? The first hominin found from the peninsula we found when we were first surface collecting this site. This is in fact the largest hominin tooth ever found, and it's coming from a Paranthropus, one of those small-bodied but big-faced, big-toothed creatures, Paranthropus, one of our evolutionary cousins. And you see damage on the bones too. All right, this is damage that you can look at right away, and if you've looked at porcupine dens, porcupines gnaw on bone. They get calcium from the bones, so they actually collect bones. A porcupine den can actually have a big collection of bones where the porcupines just wander around and they go, oh, a bone, and they pick it up and they bring it to their den and then they just gnaw on it. So you've got porcupine gnawed bones, and of course we want to be able to tell whether bones have been processed by stone tools or whether carnivores have chewed on them. So there are different ways of figuring that out. You know, one of them is to actually do experiments yourself. So this is a goat limb in my lab at Queens College, and 1 quartzite flake. And I used this 1 flake to completely deflesh the goat limb, to cut the bones apart. And, you know, I could have used it to cut the meat if I was going to eat it raw. I took it home and we barbecued it. And you could also just break the bones open, ultimately, if you had a hammerstone and anvil for their marrow. So again, this is the power of lithic technology. Just having a simple stone tool allows you to do a lot. And a goat limb is a high-quality resource. But when you're butchering an animal, you sometimes hit the bone with your stone flake, and you leave a cut mark. So there's a stone tool cut mark on the bone. And they're often very deep and have little lines inside of them from the uneven edge of the stone tool. You can also break bones open for their marrow with a hammerstone and an anvil. So this is a pounding toolkit, and the pounding toolkit was important as well. And you can look at carnivores and carnivore damage to bones. All right, I've worked a lot with this Wolf Conservation Center in South Salem, New York. There are lots of bones from deer that have been eaten by wolves. They give them whole deer carcasses. And you can look at the damage that are done by wolves, and people have looked at hyenas and lions to tell carnivore damage apart from stone tool damage. And when we were working at Nyayanga, we had some very obvious stone tool damage just from the bones that we picked up off the ground. These very deep V-shaped cut marks are stone tool cut marks. These very deep marks are stone tool cut marks. And in fact, this same bone, it's a long bone. When you look at the inside, you can see these flakes that have been blown off. This was actually hit with that. This was first defleshed, and then it was broken open from marrow. So the hominins got both meat and marrow from it. And of course, this is all being eaten raw. This is before people cooked. You've got stone tool cut marks on this shoulder blade from an antelope, a lot of muscles attached to the shoulder blade. Stone tool cut marks from the humerus and upper, the forelimb bone, upper forelimb bone. Again, a lot of meat on the humerus. So there was definite evidence of 2.9 million-year-old hominin processing of animal bones. And there were stone tools. So we've got the cutting component of the Oldowan, the cores that are being hit to knock off flakes, but also a lot of these pounding tools. A lot of pounding tools. And this is more evidence for pounding than we've ever found at any Oldowan assemblage. And in fact, these tools would have to have been pounded for 3 or 4 hours because these raw materials are so hard that you'd actually have to use them for hours to make that degree of damage on them. And that shows that the pounding component of the toolkit was very important at Nyayanga. And so the question was, what were they using these pounding tools for? Well, first of all, where are they getting the pounding tools for? It turns out that it's a lot of the pounding tools are being made out of quartzite and rhyolites. All right, these are things that are being brought down on these stream channels. They're not actually found at Nyayanga. You need to transport them. So this is a 10 or more kilometer transport distance, which for a very early archaeological site is actually a long distance, right? Usually hominins, at most sites, hominins just use the stones that are right at their feet. But because the stone right at the feet at Nyayanga is really poor quality, the hominins actually were going off the peninsula for their pounding tools and picking up cobbles of hard material and actually carrying them back to Nyayanga to use for pounding. This may actually be some of the oldest evidence of it for intentionality. They know they want to do pounding tasks. They're actually going to get the appropriate raw material and carrying it back to the site to carry out those pounding tasks. 2 of the sites we've dug are here. I'm going to show you excavation 3 and excavation 5. We've actually got hippopotamus butchery at both sites. So this is the oldest Oldowan site, and bang, they're butchering huge animals. All right, this is one hippo skeleton. Other animals are found at this site, but most of the bones are from this hippopotamus. And this hippopotamus died here. It's a death site. It's got every region of the skeleton preserved. Here are some of its teeth, all right? The enamel poking out. And everything is being shot in with laser transit. You can see that we're numbering the teeth. The teeth here are numbered. And then we shoot them in with coordinates that we attach to those numbers. And, when we were digging, so part of the hippo has been lifted here, so you don't see as many hippo bones. But what you do see is there's a very stark contrast between the brown sediment to the right of the excavation and where the hippo bones were. And that's because a fault actually runs right through the hippopotamus. So this poor hippopotamus, right, big animal, this poor animal, half of it was actually dropped 2 meters. And we actually had to keep digging for a couple of years until we found the rest of the hippopotamus. We got half of it here, and then we had to dig this side down 2 meters until we got the rest of it. So you can see these blue bones are the hippopotamus bones, and they get dragged downwards by this fault, and then you pick them up again here with stone tools. And, so here's the hippopotamus bone. They're associated with artifacts. Often the artifacts are lying right on them. That's because we think they were used to actually butcher the hippopotamus. There's some cut marks on the hippopotamus as well. And we also found other things, like this is everything's got dirt on it, so it looks prettier once it's cleaned. But this is a monkey lower jaw, a monkey mandible. And this is a paranthropus tooth, which we found the last day of the field season in 2017 during an electrical storm. And I was lifting it, and we were rushing to try to get everything out so that the people who were working the surveying equipment didn't get hit by lightning. And we found a hominin tooth right then at the same level as this butchered hippopotamus. So this is not what I expected. I would have thought that maybe we'd get a tooth from our genus, from the genus Homo, but we got a tooth from a Paranthropus at the site. Up here, there's another hippopotamus, excavation 5. We haven't fully excavated excavation 5. We're going to hopefully keep digging that this summer. And at excavation 5, you've got, again, more hippo bones. So here's a shin bone, here's a shoulder blade, here's part of the pelvis, here's the heel bone, all sort of going into the wall. So we haven't fully excavated this hippo yet. But, the bones are a little bit better preserved at this site. It's still about 2.9 million years old. There's stone tools with it. Here's the shin bone. This is where the knee would have been, so it's put on its side. So this is part of the hippo's knee and the shaft of the shin bone going down. This is the place in humans where the quadriceps femoris muscle would attach. So big muscles attach to the front of our shin bones, our tibia. And you can see that that's at the spot where you've got these stone tool cut marks. So they're actually cutting the tendon for this muscle to start stripping the muscle away. This was a butchered hippopotamus, just like the other one was. So basically, you can think of a hippo, especially if it's not trying to bite you, as a giant sack of very good things to eat. It's full of muscle, which gives you amino acids, right? You've got proteins. It's full of fat. It's got all these micronutrients, zinc, iron. So if you can get access to a hippo's great. It's very tough to eat, though, especially if you're eating it raw. So you need stone tools both to butcher it, because their skin is like a centimeter thick. There's no way you could get into a hippo without stone tools. And then you'd have to pound the meat and cut it, sort of to make hippo tartare, in order to be able to eat it. And that's what they were doing, apparently. They were eating these hippos. So this shows, again, right at 2.9 million years ago, bang, they're getting access to a high-quality resource with this simple stone tool technology. I don't think they're hunting the hippos. I think the hippos are being killed by carnivores, or they're dying naturally. But this is a hippotastic place, and there are lots of hippos all the time. You've got these freshwater springs, and every time the hominins found a hippo, they were probably butchering it. Another way of figuring out how the stone tools were being used is through something called use-where analysis. This is Cristina Lammarini from the University of Rome. And basically what you do is you do experiments with you make tool replicas out of the same kind of stones that the hominins used. And you use those tool replicas for a whole bunch of tasks, for cutting different things. You can see the things that we processed on the screen. For cutting different things, for pounding different things. You look at the kind of damage that develops on the edge of your tools. You use that as a reference to try to understand the damage you see on the 2.9 million year old archaeological tools. And Christina, we had evidence for butchery from the bones themselves. She also found evidence for butchery, both cutting flesh and breaking bones from the use-where on the tools. But you also get evidence of plant processing that would never be preserved otherwise, because the plants don't preserve. So she found evidence for tubers, dirty tubers being skinned so that they could be eaten without all the dirt, the dirty skin on them. For woodworking, right, which presumably they're making wooden tools. They're actually using stone tools to make wooden tools. And also for pounding different plant foods too. So this, again, at 2.9 million years ago, as soon as you get it, they're using these, as soon as you see it, at least in the archaeological record, they're using these tools for a wide variety of tasks. And if you see a reconstruction of how Nyayanga was formed, you had this stream channel that I showed you the cross-section of. There are wet and dry seasons. The temperature doesn't change that much near the equator. What you have are rainy seasons and dry seasons. So during the dry season, the stream wouldn't really be very full. In fact, the stream may be completely dry. During the wet seasons, the streams overflow. You may have seen, news recently about Kenya. There have been a lot of flooding in Kenya, right? So there are times where there are big floods in Kenya. Then you've got the streams overlapping their banks, and they bury whatever is alongside them. Hominins are hanging out At the edge of the streams, where you've got water, where you've got shade, where you maybe have a hippo to butcher, and then hippos are walking in and out, the hominids are staying away from the hippos because a live hippo is not fun. And then, every once in a while a hippo would die, and the hominid, this is paleo crime scene investigation, and the hominids would go and butcher the hippo and have a feast. Here's sort of a nicer view, rather than my stick figures, of a volcano in the background, a stream, big animals dying alongside the stream, and hominins actually getting meat from these large animals. That's the general scenario for Nyayanga. All right, and it may be that this big-toothed hominin, Paranthropus, is actually the one that's using the stone tools. This is 2.9 million years ago. There are lots of different hominids in the landscape. It could be that genus Homo is using tools, but the only fossils of hominin we have from this site are Paranthropus. And it could be that Paranthropus, with these itty-bitty front teeth that are no good for nipping, that would not be good for biting, and these very flat, very big cheek teeth, which are just only good for grinding. If this hominid had sharp flakes for cutting and stones for pounding, that archaeology would actually allow them, even with this dentition, to eat animal tissue, and also even to make tubers easier to digest by cutting them into pieces and pounding them. You break down cellulose if you're eating tubers raw, and that makes them easier to digest as well. So even though Paranthropus, you may not think of as maybe being a good candidate for a tool user, it could have been that Paranthropus was a tool user. Now I'm going to talk about two more recent sites, Kanjera and Sari River. These are probably made by different hominins. I would not be surprised if they're being made by Homo erectus, but I think it's likely that some form of Homo is making these sites. This is Kanjera. This is a site I worked at for 20 years. It's called Excavation 1. It's a 169 square meter excavation. We dug it in 1 centimeter squares and 5 centimeter spits, so little 5 centimeter levels. Everything's shot in, like I said, everything that's important is shot in or bigger than 2 centimeters. And, this is what you get when you piece plot everything. So the fossils are in red, the artifacts are in blue, and you can see this is a really dense concentration of stone tools and fossils. You don't get this kind of density at the 2.9 million years old site. This is, hominids going back to this spot repeatedly and leaving a big garbage pile of stuff over many years. In fact, we know it's many years because you can see in this vertical distribution, which is about 3 meters, so that would have been probably hundreds of years, that the hominids are actually depositing the stone tools and the artifacts through that whole 3 meter sequence. And they seem to be doing the same thing all the way through time. This is a favored place, all right? This is not, it's not like a campsite. This is a site that's attracting hominids repeatedly over time. And we don't know why they're being attracted there. We know what they're doing there, though. And we'll talk about that in a minute. But something is attracting them to that specific spot. And they're going there over many, many years. It's like a picnic bench. If you go to a park and there's a picnic bench, people are going to keep sitting at that picnic bench under the tree, and some of their food is going to fall on the ground, and some of the metal bottle tops and things will fall, and eventually you'll have an archaeological site at that picnic bench just because people keep going to it and keep using it and dropping their stuff. And that's what these early archaeological sites are. So here you've got bovid mandible and a bovid. This is a lower jaw from an antelope. This is part of the pelvis of an antelope. This is a zebra tooth. This is a long bone shaft, a shaft of a bone. And there are flakes, right? So here's some stone flakes. And that's the Queen Mary for scale. And here you can see the bones, right? There's a lot of bones at this site, but these are not huge hippo bones. These are mostly small antelope bones. All right, here you've got part of a shoulder blade, and again, flakes that are 2 million years old, but are still sharp. And you've got a lot of raw materials here. Kanjera's got probably the richest raw material assemblage of any archaeological site in the world. A lot of these are coming from off the peninsula. They're being transported in. The chert, the felsite, the quartzite, the quartz, the granite, these are non-local raw materials. So even though Kanjera is found, more than 10 kilometers away from the source of these hard rocks, the hominids are carrying these hard rocks around with them, and about a third of the archaeological assemblage is made up of stone tools that are not from the mountain, but are actually coming from off the mountain. So this shows that adaptively, that having a hard tool is important, because they're actually using energy to go off the peninsula and get them. And when they're foraging on the peninsula, they've got these nice raw materials. And they flake these nice raw materials, these exotic stones, the ones that are coming off the peninsula. They're flaking them much more carefully and getting more flakes per stone off of the exotic ones than they are the local ones, which they flake much more casually. And so they seem to really appreciate the hardness. Christina has also worked on these artifacts. And again, we've got evidence for butchery, and she has evidence for butchery in the useware, but also a lot of plant processing, woodworking, tuber processing, herbaceous plants, right? So something you could make twine or baskets from, perhaps, right? So they're working all of these different materials with their Oldowan tools. There are a wide array of animals found at this site, but the ones that are most common are on the left-hand side. Antelope, especially, like more than 70% of this assemblage is antelope, zebra and pigs. All right. And this is a very open fauna. So seeing this grass here is not a mistake. This was actually formed in a grassland. So this is some of the thousands of bones we have from the locality. These are all little antelope bones. And you can find stone tool cut marks on them. All right, so it's this fragment. This is actually the hip joint. It's the part of the thigh bone that sticks into your pelvis. And that's, as you can feel on yourself, that part of your body is just covered with muscle. It's covered with meat. And they were cutting that meat off, and that's why they left stone tool cut marks at that spot. There's also percussion damage. So you've got these big notches, right, from smashing the bones. This is actually a zebra thigh bone, so it's got very thick. It's a very thick bone. You've got to smash it really hard with a rock to break it open. So that left these big indentations in the bone. These pits and with little lines coming off them are also from the bone being struck with stone tools. Here's some carnivore tooth marks. There are some evidence of carnivore activity, but it's not very frequent. In fact, here's a very cool fragment because it's got both hominin damage on it and carnivore damage on it. We've thought that the hominids were processing the material first and then leaving it, and carnivores were coming in and scavenging. And that's what actually this one bone shows. Here's a stone tool cut mark. So the hominids were cutting meat off it first, and that's actually overprinted by a carnivore tooth mark, a carnivore that followed the hominin and then was chewing on the bone. Here's a really cool little vignette, behavioral vignette. You've got an anvil, and there are bones around it, and some of these bones have percussion damage on them. So this is a 2-million-year-old snack spot where a hominin took an anvil, smashed some bones open. You can even see the damage on the bones from the anvil on one side and the hammerstone on the other. These bones were smashed open so the hominids could eat the fatty marrow, and it was a nice snack, a good break from eating, tubers or some other plant food that wouldn't be as nutrient rich, or as fatty, I should say. And most of the remains, there are 1583 bones. There are at least 81 antelopes from this site. Half of them are juvenile. And these look like they're small antelopes that are being hunted repeatedly because we're getting partial skeletons of antelopes, right? You've got bones from every region of the skeleton represented there. They show stone tool damage on them. There are not many there's not much carnivore damage on them. These are adult mandibles. A lot of the mandibles, though, a lot of the lower jaws show that the teeth were not fully erupted. These are juveniles. Some of them are even babies, little tiny antelopes. And this is what you would expect from an animal that's hunting in a grassland. It's much easier to catch the juveniles than it is to catch the adults. And living carnivores that are hunting, like hyenas and cheetah that are hunting in grasslands, catch many more juveniles, wild dogs as well, many more juveniles than they do adults. And that's what we have here at Kanjera. I think this is a hunting signal. It's the oldest evidence of hunting we have. They're in an open grassland setting, and just like the cheetahs and the hyenas, they're hunting the small gazelles and then butchering them. All right, another site that's kind of cool that's nearby is this site called FWJJ20. It's the same age as Kanjera. It's up in the Turkana region. And the reason why I put it in is that they're eating aquatic resources here. So they're eating fish, they're eating crocodiles, they're eating turtles, right? So this shows that with this Oldowan toolkit, you can live in different habitats, and you can use the tools to process pretty much anything that's in the habitat you're in. So it really improves or increases the adaptability and behavioral versatility of the hominins that are using them. All right, this is this final site, Sari River. We've been working here most recently. It's a 4-kilometer site, so it's an enormous site. It doesn't have a lot of fossils preserved, but it's got thousands of stone tools. This is one site we excavated, just 12 square meters and almost 2,000 stone tools. So again, these sites that are 2 million years and younger have really dense archaeological occurrences. All right, these are just these little tiny fragments, so many stone tools all over the place. And we've excavated 5 sites in this region, and you can see, we wanted to get a sense, is there just a smear, an even smear of artifacts across this ancient landscape, or are there particular spots that the hominids seem really interested in? And from Kanjera, it seemed like there are particular spots these hominids are really interested in, these favored places. And you can actually see the favored place on the Sari River landscape. There are 24 artifacts here, 10 here, 4 here, 56 here, and there's 1,600 artifacts here. This spot was a hot spot. For whatever reason, they really liked this spot, and they were going back to it repeatedly. And in fact, this is the vertical distribution. So you can see, this is a meter. You can see that they're going back to this repeatedly because these artifacts are distributed through a meter of sequence. So again, something really interesting is going on here behaviorally that's probably very different than what you have going on at Nyayanga. So at Nyayanga, just as sort of a recap, you've got this very early Oldowan. It seems to be adaptively significant at its first appearance, right? The Oldowan, that's the Oldowan in general. It's more widely distributed across Africa early on than we thought originally. It's being used, we can tell from Nyayanga, to pound and cut a wide array of materials. So this would really help the hominins, whatever hominins making them. It would give them access to foods that they could not access without stone tools. It gives them access to packets of food that are large enough to share, right? This could be just hitting a stand, using digging sticks to get deep tubers that have a lot of starch, and you can dig up a bunch of tubers and share them, or it could be a hippopotamus or an antelope that you can cut tissue off of and share. And you've got some movement of stone that's interesting, like these cobbles that are being used for pounding that are being carried for 10 kilometers. All right? That suggests maybe of some intentionality, of some foresight, planning of tasks that are going to be carried out and getting the appropriate technology to carry out those tasks. Later on, where you've got Kanjera South and Sari River, you've got hominids foraging across different habitats. I mentioned FWJJ20, including aquatic resources being used, right, like fish and crocodiles and turtles. At Kanjera South, they show they really favor the high-quality raw material. At Sari River, the high-quality material is right there. So that's actually the only place where you don't have to transport the high-quality raw material. It's right there in the conglomerates at the site. At Kanjera, they're still transporting this high-quality rock because it flakes more easily, it holds an edge longer, and it allows them to do more with a kilometer of rock, a kilogram of rock, not a kilometer of rock, a kilogram of rock than they could have with the local soft, crummy rock. They're making tools with tools. I'm sure they're making wooden tools. I wouldn't be surprised at all if they're making simple spears and digging sticks. And they're showing persistent carnivory. So I think they're showing hunting, and this hunting isn't just something that happened once. You have this hunting going through 3 meters of sequence. They're repeatedly hunting over hundreds of years. That shows that hunting is an important part of their behavioral repertoire. So, and they're also eating tubers, which are high-quality, starchy foods. Is this a shift then to tool-dependent foraging? I think probably it is. All right, certainly by 2 million years ago, I think that shift has occurred. So this shift in diet is what's shifting the major changes you see in the hominin fossil record. A shift in body size from a small chimpanzee-sized Australopithecus to a human-sized Homo erectus, and increases in brain size from again, something that's about chimpanzee-sized Australopithecus to Homo erectus. It's got twice that brain size. And brain size expansion continues on beyond Homo erectus to creatures like Neanderthals and Homo sapiens, which have very big brains. The other thing you get when you rely on technology is jaws and teeth don't have to be big anymore. And this technological explanation for these changes in the hominin fossil record also is sort of tested by looking at the jaws and teeth. Jaws and teeth in the genus Homo, in our genus, get smaller over time. And that's almost certainly because they're using more and more sophisticated tools over time, and they're processing food outside of their mouth. So if you don't need to have giant jaws and teeth, and selection is relaxed on those, then tooth size and jaw size actually reduce over time. And that's what you see in the fossil record. It's almost certainly a reflection of increasing tool use and improved tool use. So you may think that looking at an iPad is so cool, or having an iPhone is like technologically the most important pinnacle that humans have reached, but it's not. If we hadn't had these simple stone tools, we would still be bipedal apes living on the savannah. Thank you very much.
Thank you. Thank you very much for the lecture. And in just 15 minutes, we will meet here again in a slightly different situation. We will have the opportunity to ask questions. I'm sure I have a lot of them. So for now, let's take a short break and don't leave, because in just, I'm going to say 12 minutes, we're going to meet again. Thank you. Dobry wieczór, Szanowni Państwo. Oto i sesja pytań po wykładzie profesora Thomasa Plummera. Tak jak i poprzednie wydarzenie, to będzie od tego momentu działo się już w języku angielskim. So the plan for the next 45 minutes is that if you wish to ask any questions, I will probably start with some because I have noted quite a lot actually, things that I would like to ask about, and I will use my privilege as a host to be the first one. I will definitely ask people here in the audience for your questions, and I'm also monitoring things that are happening online, so if you are watching this live, feel free to write in the comment section, and I will attempt to find useful questions. And this is basically it. I mean, the visibility is bad. I mean, we are very well lit, and I don't know, I don't see anyone, but I will do my best to find bright objects waving. But allow me to kick off with very basic questions, because I think later we will get to issues such as, you know, the grand history of our species, but I would very much like to begin with methodology, really. I don't know if I'm the only one who's fascinated by the idea that you basically have a stone, an artifact which is somewhat simple, and then you have this extremely complex deduction based on an artifact. And I've actually read a very interesting paper about how you can make an error in judgment. You find a piece of rock and you classify it using all the standard methods of, you know, anthropology and paleontology, paleoanthropology, and then you would decide based on this method that it was actually a tool, but it was in fact produced by trampling. People just stood on a piece of rock and it left marks which you would think were made on purpose. And I was wondering, while reading this paper, do you have these sort of fears that it's wrong? I mean, we've seen these fantastic slides of cut marks, and I don't know if I'm the only one who had this thought. I mean, are you completely sure this hasn't been something that just landed on a rock in a weird way? How confident is the method?
This is something that archaeologists have worked on for a long time. So this is something that's being debated all the time. So the methods, you know, when you do an analysis of the history of site formation, you've got to be really careful and think about all of the possible alternatives. So we do think about possible alternatives. Now, the reason why we're confident of the marks on the bones or that the stones are tools is that you've got, first of all, the full set of production at the sites. You've got the stones that are being used as hammerstones, you've got the cores that have the facets on them, and you've got the flakes. It's all together. And you know, what's key is having them together in a very fine-grained sediment, where you wouldn't have other objects banging them around. So these are actually found in silts or clays that were coming, you know, being deposited by the stream when the stream flooded. And the flood wasn't coming out as a gushing torrent. It was overbanking the bank. The water was going over the bank of the stream and then passing over the land and dropping silt. And that is not a velocity of water that's going to bang things together. There's no evidence in the sites I was talking about for trampling. And the artifact edges, which are being looked at microscopically by my colleagues who do the use wear, they know what natural damage looks like on an artifact edge versus behavioral damage. So you know, that's another check that's done at the microscopic level that shows that they are pristine artifacts.
And if I understand, a certain part of the methodology of your branch of science is doing experiments. How important is it? Because I recognize it as a common part of many papers that we have done something like this. We attempted to create this tool or to cut meat You've shown us how you have portioned a piece of goat meat. Did it enter a certain study, or was it just your free time activity?
It was more for me I was doing a cut mark study actually, so it was
Yes.
more about the cut marks than it was about the stones. And I was working with actually a butcher at a halal shop near me, and I would bring stone tools to the butcher most of the time because I wanted an experienced butcher to do the butchering. So most of the time I was buying parts of a goat, and he liked me, so he humored me. He would take my stone tools and actually butcher whatever I bought with my stone tools. So I wanted to have an idea of where the cut marks would be and how many there would be on goat limbs that were butchered by an experienced butcher. And then I was also doing it just as a comparison.
Yeah. And again, I thought I entertained from time to time in the context of these studies. We have contemporary people, Homo sapiens sapiens from the 21st century, attempting to recreate a certain procedure from 3 million years ago, and you, for instance, you are trying to recreate cut marks left by people 3 million years ago. Again, is there something in the way that we would do it that they wouldn't do it? Can we believe that we can actually do what they were doing? In other words, for instance, this was a butcher who had an experience with using modern butchering tools, so his movements would be completely different from movements of someone who just had a piece of rock 3 million years ago and was from a different species, really. So can we trust these experiments where we try to do something? Aren't we too modern, or do we think differently?
Well, the reason why I was using an experienced butcher is that the anatomy of the animal actually puts some constraints on where you're going to cut the meat off. So actually, if you were going to butcher something well, then you're going to be cutting off certain portions first that will allow you to strip sections of the meat off. You'll be cutting a tendon, cutting fascia a certain way. And that would be true whether you're a Homo erectus or you're Homo sapiens. And that's actually determined by the anatomy of the prey animal. That's not determined by anyone else. And then in terms of the cut mark morphology, there are people who are doing super sophisticated scanning analyses of marks, like a guy named Mike Ponte in Colorado in the United States. And he's 3D scanning marks made by all sorts of creatures, and then putting in these ancient marks as well. And they are getting, the ones that you might think were cut marks are frequently being attributed to cut marks by AI as well. So you're talking about machine learning. Machine learning is actually being used to identify marks on bones too, to carnivores, to crocodiles, to cut marks. So I think this just has to do with the physics of a sharp stone edge being dragged across the bone, and the mineral composition of the bone, and how that bone reacts to an edge of that, durability, and that with that much force being put across the bone. So actually, I think there is there are physical constraints. You're not just going to get random marks on the bones.
But it gives you confidence that we can take this piece of stone from 3 million years ago and actually cut meat with it, right? Because I think if
you could actually, some of the stones.
It works. It works.
Some of the stones are so sharp you could still do it, like when you excavate them. And obviously, the pounding tools you could still be pounding with.
Yeah, pounding is easy.
Pounding's easy.
Than cutting meat.
I think it's important, though.
And what is your reaction to a more, to stories about, you've shown us an image from a show on Discovery Channel. Mm-hmm. I don't remember the name of the show, but it was basically people trying to live as if they are primitive people.
They're just trying to survive.
Yeah.
So it's called Naked and Afraid.
Oh,
they're not modeling any primitive people.
Yeah, exactly.
It's kind of like, I don't know. It's just a survival show. It's the premise is kind of dumb, but I find it's like eating popcorn, like you can't stop.
Yeah.
So I do watch it just because I want to see how the people are going to get by. I want to see how they're going to get food.
But there's nothing like, because if I can take a tool from 3 million years ago and actually cut meat with it, it kind of gives us confidence that we understand that it was actually used for cutting meat. But is there any truth to the idea of taking a human and putting him naked on savanna and watching them for a couple of weeks and then saying, so this may have looked like, or is this just complete nonsense?
Yeah, I think it's more just seeing how they get by and showing that technology is really critical for any kind of survival situation. You need technology. I think if you want to actually look at how people forage, how people properly forage, then you go study the last peoples on the planet who are still foraging, like people in Eastern Africa or the Inuit or the Hadza in East Africa, things like that. And you see what they do because they have a long tradition of it in those landscapes.
But they are contemporary people, right?
They are.
They also evolved for thousands and thousands of years.
But they could give you ideas of just, so say you're looking at the Hadza, they're living in the same kind of environments generally that our ancestors lived in. They're eating a lot of the same foods almost certainly that our ancestors would have eaten. And you can just see what they're doing with different technologies in that environment. And even if it's not exactly what you're thinking about from your archaeological site, it may make you think about something in a slightly different way from seeing people survive in those sorts of environments. Just like studying baboons or studying chimpanzees can give you insights into thinking about human behavior too.
Okay, one last attempt at mixing entertainment with science. I used to watch one of those primitive technology channels on YouTube. I don't know if you're familiar with the premise.
Mm-hmm. Yeah.
And it was actually, the father of all, this guy in Australia who attempted to recreate certain technologies. So he actually taught himself to, make fire and make clay utensils and so on and so on. And there was a certain natural progression that he had to build tools to make tools and so on and so on. So it was, to the best of my knowledge, it wasn't completely fake, like a show on Discovery Channel. It was an actual human being trying to start with nothing, actually with stone tools, really.
Right.
And then progress. Is there anything, is there food for thought for someone like you in watching these people?
Yeah. And in fact, I co-teach a class with a gentleman named Ryan Chin at Queens College, a course called Ancient Technology, where we're actually doing that sort of thing. And I've learned a lot from it. You can read about people doing things in a textbook or in a paper, but then when you actually try and do it yourself, you see what all the problems are. And you get a much deeper appreciation for what our ancestors were doing.
Okay, so let's...
So I think it actually is useful to look at those sorts of videos, and some of the people on YouTube are actually incredibly talented.
Yeah.
Yeah, very, very good.
I was flabbergasted by what he was capable of doing, starting from rock, and okay. So at the time that these, can I call them people? 3 million years ago, these.
Yeah, I don't call them humans or people. I call them hominins, just because that's a technical term, and that's safer. Like right. I would call a Neanderthal a type of human.
All right.
Neanderthals are close enough to us that I would call them a type of human. But like before Homo erectus, probably I wouldn't call them human.
Okay, these. Them, the hominins, all right.
Hominins, yeah.
At the time that those hominins that left those stone tools, what else did they had or might have had in terms of technology, but it just didn't, we can't see it because it just, this was destroyed throughout the 3 million years. It didn't last. What also did they have? Or
I think probably they're making tools with perishable materials. Most of chimpanzee technology would not preserve, but they do. Actually, people don't know about this, or a lot of people don't know about this, but you can excavate chimpanzee sites. There is chimpanzee archaeology. I'm not sure they call it chimpanzee archaeology, but it's essentially chimpanzee archaeology where you're actually excavating sites And some of the sites where chimpanzees are using stone cobbles and anvils to process nuts, some of those sites go back hundreds of years. So we're not the only species that has an archaeological record. Actually, chimpanzees have an archaeological record. But most of their plant tools don't preserve. And I would think, every time you do use wear, at least every time we've done use wear, the 2 sites that we've done use wear, and we're going to start doing it at the third site as well, there's always a lot of plant material being processed. And I'm sure they're working wood, like at an early time. And I would think that, whether it starts off as a pointed stick is something that is not conceptually very difficult. If you've got a stone tool and you just sharpen the end of a straight branch, a pointed stick can be used for so many things. It can be used for your defense. It can be used for hunting. It can be used to dig up tubers. I think some sort of digging stick, spear technology, even though we don't have evidence of it, I bet it's showing up very early. Just because I think it's very powerful and conceptually not very difficult. So I think once someone came up with it, probably it would spread very rapidly through the group.
Are there maybe any questions here in the audience? I will do my best to see, and there should be someone also with a third microphone, but I have no idea. Okay, let's just do it like this. Is there someone over there with a microphone who can take questions from the audience?
I also wanted to make another point about the pointed stick.
Oh yeah,
There's a
sorry.
population of chimpanzees that uses their teeth to sharpen a stick, and they use that as a probe to kill little nocturnal primates in their holes, and then they eat the little nocturnal primates. The Fongoli chimps. So they actually basically make, what very primitive pointed sticks. You might consider them very primitive spears. So that's even happening in chimpanzees.
Yeah. Is there someone who's going to help me in taking questions from the audience? Oh, thank you, Łukasz. So I will defer to you with also selecting questions, because I don't see anything. Thank you.
Yes, hello. Are there any evidence for that these tools were using to kill or in fights between the hominids, maybe between different groups or in one group? And this is my first question, and let me ask about second question. Do you think that the climate changes and urbanization of the Africa and maybe the political situation make the job of the paleontologist harder in the future? Thank you.
All right, so the first question, there are hominin fossils that have marks on them which are difficult to interpret. There are a number of Neanderthal sites where the Neanderthal bones have cut marks on them, and some people have interpreted them as evidence of cannibalism, where one, it could be either they're eating individuals within their group who die, they're hard up and they're hungry and they're eating them, or actually one group is capturing another group and butchering them. And in those situations, the idea is that you look at the bones of the hominins and you compare that to the bones of prey animal from the site and see if the hominin bones are being treated the same way as the prey animals, say reindeer. And if the cut mark distribution and the breakage for marrow extraction, if it looks very similar between the two, then the idea is that maybe those hominins are actually being eaten. So that's been seen for some Neanderthal sites. There's a site in Spain where there are cut marks on some hominin fossils that are about 800,000 years old. And again, those are interpreted as having been actually butchered and eaten by other hominins. So yeah, there is some argument about that, and there are other examples as well. But there is discussion that there are times where it may be that hominids are actually being consumed by other hominins.
And the second part of the question was about doing science.
I think, one of the sad things about climate change is that the parts of the world that are least responsible for the climatic, for producing CO2 and driving the climate change, are the parts of the world that are often going to be the most dramatically affected. And that's true for a lot of Africa. A lot of Africa is going to be affected very badly by climate change. I think how the region I work in is going to be affected is that the rain is going to become more erratic and more deadly. So there'll be times where the rainstorms will actually be even more intense than they would have been on average in the past. And that leads to, like where I work, erosion is washing the sites away. So where I work, sites could be eroded away over time by the rain. And you can already see sort of the rain shifting over time. Just like you see, I'm sure you see your winters changing. The winters where I live in the northeast of the United States are definitely much, much milder now. I've lived long enough that I remember what it was like when I was a child. And my winters now are much milder than the winters I grew up with. So parts of Kenya are going to become more arid. The top half of the country is already semi-arid. So those are going to become more arid. I think rainfall is going to become, which is so critical there, is going to become, less predictable. And I think there could be times where you have very intense rain events. And, all of that's going to affect everyone there. And in terms of erosion and my work, it's going to affect the erosion of the sites.
Do you have...
Yes, other questions?
Good evening. I have a question regarding chimpanzees you mentioned before. So is there any evidence you know of that they actually do use and make tools instead of using ad hoc tools as like, let's say, random branches, but do they actually do sharpen them and actually plan on making tools?
Yeah, they're making tools. So, with the branches, they're finding twigs that are the right diameter. They're stripping off the leaves. They may smooth them a little bit with their hands. So they're making them so that they're a proper probe that they can use to go into the termite mound. They'll take leaves, chew them in their mouths to make like a sponge, and then they'll use that sponge, that natural sponge, to get water from streams. So they do that quite a bit. They have a sense from experiments that people have done with them. They pick the right kind of rock for napping tasks. So if they will use appropriate rocks. They seem to understand the physical properties of different rocks and use the appropriate rocks for nut cracking, for example. So chimpanzees are pretty sophisticated. There's good experimental evidence that they learn well by observation too. So there's not a lot of evidence of them teaching each other, but chimpanzee babies spend a lot of time with their mothers, a long time. That's why reproductive output is a little bit slower in chimpanzees than in humans. And the mother, it's actually female chimps that use tools more than males. So female chimps use tools the most. So a lot of tool use is probably learned by infants actually observing what their mom is doing and then trying to copy what their mom's doing as they get older. So yeah, I think the chimpanzees, I don't study chimpanzees, so I don't know it as well as probably I should. But from my understanding, chimpanzees are actually, making tools. They're not just taking a branch off a tree and then using that branch with the leaves on it and everything as a probe. They're actually shaping it to make an appropriate tool.
Is there another person lined up, or can I interject? Because I actually have a
There is one question.
Excuse me? Yeah? All right.
Thank you. Good evening. I have a question. You said that chimpanzees are learning by observing. What do you think about communication between these hominids? Because preparing such complex tools, such sophisticated tools like these flakes, it needs communication, more communication than observing?
So does the Oldowan require communication? Is that what you're saying? The Oldowan tools? Yeah. That's something that people are debating quite a bit, and people are doing different experiments with novice tool users just to see whether, how difficult it is for them to learn just by watching someone else making Oldowan tools and by having the appropriate rocks in front of them, whether they over time can master the Oldowan. And I think you probably can learn how to make Oldowan tools simply by observing other individuals. Now, there could be teaching going on, but I think if you sit and watch, you can probably get a lot of the technique for that. And then it's just a matter of how often you practice and how good you get. But there's a tool industry that follows the Oldowan called the Acheulean, where they're making tools that are fancier than the Oldowan, that are, I don't know if you've heard of the Acheulean, but too bad I should have put a slide of the Acheulean up. They're tools that are teardrop shaped, and they're flaked all the way around the perimeter on both sides. And most people think that those tools actually require some teaching, like to make them, and that's what you get, actually Homo erectus. So I talked about Homo erectus today. Homo erectus develops Acheulean tools. And when people have done experiments in the brain, looking at Dietrich Stout, like at Emory University, is one of the people that's done this, looking at the parts of the brain that are active. So you do an imaging, a PET scan, so you can see what parts of the brain are active when people are making these fancier tools called the Acheulean, and also when they're speaking. Some of the same centers of the brain that are active for the tool use are also active when you're speaking. And those are centers of the brain that have to do with ordering, have to do with putting things in the proper order. So knocking off flakes in a certain order, or syntax in language, putting words in a specific order. And some of those regions of the brain are actually being used for both tasks. And Dr. Stout would argue, and a lot of people I think would argue this too, that there's probably coevolution between language and stone tool use, that they're mutually reinforcing each other. And individuals who are really good at making stone tools, may also have language areas that are a little bit better developed too. And those individuals will they may have more reproductive success. They might be more successful over time, and these traits will be passed on. And ultimately, you'll get, better language and better tool use being co-occurring over time.
I will, interject because I wanted to ask something, and it kind of ties up to what you said.
And I'm not an expert on that at all, so I'm just saying, but maybe you asked me a question, yeah.
Okay, you wanted to continue with?
No, I'm just saying I'm not an expert in that.
All right. I was wondering because, you are obviously interested in stone tools, that's your thing, but we've talked before about how much there is that's not, we don't have access to. And in those cases, I'm always wondering, don't we overestimate the importance of these tools in the lives of those hominins? There's probably tens or hundreds of things that would happen in an ordinary day of those hominins. I'm going to just say people.
Okay.
Those people, those pre-people. And, making the bedding or not, cooking, eating, taking care of your kids. Maybe there was a camp, there's just so much happening. And what you do with those tools can change. And then you have all the, soft matter around you, I don't know, baskets possibly, who knows, right? And so on and so on and so on and so on. Taking care of the elderly and, burials possibly, or maybe not then, but you know what I mean, yeah. Right? Mm-hmm. So there's so much in human life. And how important were these tools for those people, really?
Yeah, well, again, that's something that, because we don't have a time machine to go back, that's something that can be debated. So the lines of evidence I was using were, are they bothering to transport the higher quality stone? If stone quality didn't matter to them, they would just be using the soft stone that's right at their feet. They wouldn't be transporting the stone around at all. They would just use whatever they could find locally. So they are making an energetic investment in stone. They are picking up the better stones and carrying them around with them. And then what sort of tasks are they doing with those stones? So the butchery is something that's not happening every day. I mean, even modern hunter-gatherers frequently are not butchering an animal every day. But even if it's not a daily part of their diet, it may be a critical part of their diet for the nutrients that you get at the times that you do have an animal that you butcher. And there are, like, I'm sure they're getting a lot of calories. I'm sure, like, even modern hunter-gatherers, if there are fruit trees that are fruiting in the wild, they'll spend time eating those fruit, and that will be a really important component of their diet for that day. And they don't need tools to eat those fruits. So I'm sure there are lots of tasks they're doing that they're not they're not using the tools for. But if they're also making tools with tools, which again is a supposition, but I'm not sure why you would work wood unless you're going to do something with that wood, then that's actually sort of an expansion of what they're using the tools for. It's not even just what the lithics are being used for, it's also then what they can do with those wooden tools. And many people think that what allowed distant hominid ancestors, not like Australopithecus, to survive in savanna settings was that they were starting to eat as a food during the dry season when there's not a lot else to eat, that they're starting to eat underground storage organs. And that, with digging sticks, so that they would have been important. You'd have fruit during the wet season or during seasons when trees are fruiting. And then as a fallback food, just to get by, during starvation times, you could be eating raw tubers just to get by, like warthogs do and naked mole rats do. I mean, those are other animals that eat a lot of underground storage organs, a lot of tubers. And then if the hominids are really focused on sort of getting meat and also expanding the kind of tubers they get and getting deeper tubers and bigger tubers, then tool use is really becoming more important, not just for plant food, but also animal food. And really, if the tool use is allowing you to extract food from whatever environment you're in, so if you're along a stream and you catch a turtle, you're butchering the turtle and eating it. I mean, if it doesn't matter whether you're up on a hillside or down by a river and you're eating different foods in different places, I think what the power of the toolkit is it increases your adaptability so that you can extract resources from a range of habitats instead of having to eat the same resources in just one set of habitats. I don't know if that helped, if that was an answer that you wanted or that answered your question, but.
I was just wondering what was, I've seen many graphs that would, present human brain size. You started with, the increase in brain size in hominin history, and it was spectacular. I don't know. I've heard that nothing like this has ever happened in animal evolution, an organ being 3 times the size within 1 million years. I believe it's really rare. And it was overplotted with, tool complexity, for instance. And the presumption was that one has something to do with the other. Mm-hmm. That, because we had to produce more complex tools, then maybe, it had something to do with larger brain. And I'm always wondering how many different factors are there that we have no idea about because they don't fossilize. So to ask the question differently, what would be your best guess as to what was the game changer? What was the key thing that actually moved us from, just bipedal apes to what we are?
Right, and this is also important because people can have a very sophisticated technology overall, but their stone tool technology may look kind of primitive, and that's because they're doing more with other materials, and that there are examples like ethnographic examples of that for humans even, where human groups might have a very sophisticated technology, but the lithic technology doesn't look that fancy. And I think partly in Europe we're biased because, you know, you've got the whole, with the Upper Paleolithic, you get some really fancy tools, but that's not the case everywhere. And Neanderthals were making very difficult to make fancy tools, and ultimately they get replaced. So I think the game changer, you know, is, you know, to me, the game changer is basically one that's going to have great downstream consequences in sort of an evolutionary stream. And I think shifting towards, you know, tool use, and tool use becoming more and more important in the life ways of the hominins, I think that had lots of downstream consequences in terms of getting, you know, it affected food sharing probably, because you're getting access to foods that kids can't get. You know, chimpanzee kids can go out and they can eat fruit with their mom, but they're not going to go into the trees and hunt colobus monkeys, and which chimpanzees do. And you know, even when you catch a colobus monkey, it's not that big, and you're not going to get a lot by sharing it. But if you're going to start relying on food resources that require a wooden tool, like deep tubers that are difficult to dig up, or animals that you have to hunt, then those are food resources that children won't be able to get, and you'll have to start, your system, your way of life, is going to have to include more and more provisioning of children as you shift to those resources. So there are a lot of down the stream consequences, so that affects food sharing, and that affects how groups interact and how groups take care of their infants. I think there are lots of downstream consequences of using stone tools. And, you know, initially it may have been just seasonal, or it may have been incidental, and it may be something that intensifies over time. So what we're seeing at 2.9 million years ago, maybe the hominids weren't using the tools that often. Maybe, you know, they have a hippo and it's great, all right, great, we're going to butcher the hippo, there's a dead hippo here. But most of the time they're eating things that don't require tools to process. And by 2 million years ago, you know, something's changed, and they're using tools much more frequently, and that's why you've got those really dense sites and repeated utilization of specific points in the landscape. I don't think it's something that happened all at once. It's something that's happening gradually. But I think the adoption of tool use and it being used probably more and more over time had, you know, great significance for our evolutionary history.
Okay. I think we have time for a question from the audience. Are there any people willing to engage?
I wanted to ask about the methods used to determine the age of those tools, and about how sure are you that those tools are indeed 2.9 million years old, or maybe you're just overestimating it or something.
Right. Well, the tools, the age that I'm sure the tools are is between about 2.6 and 3 million. So we've got multiple different methods. We've got something called magnetostratigraphy, which looks at the flip-flops in the Earth's magnetic field over time. And we've got something called biostratigraphy, which is looking at the kinds of animals that are alive, and different species live at different times. So the pigs, the elephants, and the equids at this site are all suggesting this time interval between about 2.6 and 3. The magnetostratigraphy, which is, I don't know if you've heard of that before, but that's looking at, today when we go outside with the compass needle points north. There are times in the past where, in fact, the whole Earth's magnetic field was flipped. And if you went outside with a compass, it would actually be pointing to the South Pole, not the North Pole. And you can actually, that's actually recorded in the sediments by the way little microscopic particles of iron align themselves. So you can actually take sediment samples through the sequence and see whether the Earth's magnetic field is as it is today, which is normal, or whether it's reversed, whether it was flipped. So that also gives you a sense, if you can figure out which normal or reversed step you're in, that gives you a sense of the age of the site. So the faunal suggests, older than 2.6. It's actually a normal magnetic period, which actually falls in that time interval from 2.6 to 3. And then we have some absolute dates. Absolute dates actually give you, an age, right? And we have dates on apatite crystals that are at 2.9 million years ago. And that's what's really sort of pushing the 2.9 million year age, as well as some detailed features of the magnetostratigraphy. So I'm confident that we're in the 2.6 to 3 million year range. So it's definitely the oldest Oldowan site no matter what. But the apatite crystal dating is at 2.9. And we've got some other dating methods which aren't published yet, so I can't really talk about them, which are also supporting the 2.9 million year age. And we're going to keep doing dating. Dating is, I think you bring up a really important point. Dating is key, and geology is key. So that's why I said that geology is like 70% of what we do. We've got like 3 geologists coming out this summer, and they're going to keep doing other geological tests to confirm our dating. And basically what I want to confirm is the 2.9. I'm very confident in the 2.6 to 3. But I want to confirm the 2.9, which we have already 2 methods that are suggesting. But because we're, this is the oldest Oldowan site, I want to make sure that we have like many dating methods just to show that, because it is a very ancient site. But I think we're in the right ballpark. I don't think we're way off. And there are other aging techniques like argon dating, which give you super accurate dates. They just don't work where I am because the volcano where I am, the Homa Mountain volcano, didn't produce crystals that can be dated with argon dating. So we're having to use other techniques.
The apatite crystals, but they're in the biological matter, or
they're not bioapatite. They're apatite that are produced in the volcanic event. It's a carbonatite.
So in the sediment.
It's in the sediments.
Right.
It's actually in the tuffs from this volcano. This volcano actually is rich in calcium carbonate. It's a weird chemically weird volcano. So it actually produces apatite crystals.
I think we have time for a last question from the audience.
Yeah, I see raised hand.
So I wanted to ask this question because quite often in popular science, some different types of animals are being compared, for example, to young children, to give a general view of how intelligent they might be. And I was just wondering if maybe you have an idea about those hominids, how smart they could have been. Not to necessarily compare them to children, but maybe even, for example, can we compare them to dolphins that are supposedly intelligent, but they don't have hands?
Right. This is something that's always difficult to say. I would think, when people first started studying chimpanzees, our conceptions of what they could do was very limited. And as people have studied chimpanzees more and more, they're getting more and more appreciation for, what they're able to do and how sophisticated they are, how their vocalizations can mean things to other individuals in the group. I mean, there's a lot of work being done on chimpanzee vocalizations right now. Again, I'm not an expert on that. People didn't know that chimpanzee used tools initially until Jane Goodall started seeing chimps at Gombe using tools. And then now every chimpanzee community has a tool kit, and those tools are actually passed on from generation to generation. So tool use is something that's been demonstrated in chimpanzees. Observational learning has been demonstrated in chimpanzees very clearly. So chimpanzees are very good at mimicking what other individuals do, and that's sophisticated as well in terms of their intelligence. There's social relationships and how they understand who's related to whom, and so a lot of, actually social interactions give you a window onto intelligence too, that's not even technological. And chimpanzees have very rich social lives. So I would think that the hominids that we're studying are at least the level of what you would see at chimpanzees. And I would say, at the later sites, like at the sites like at Kanjera and Sari River, probably, beyond what you see in chimpanzees. And certain things like at Nyayanga, if they are picking up cobbles with the intention of using them for tasks 10 kilometers away, then that's not something that you typically would see in chimpanzees. That would actually be suggestive of some sort of insights that are beyond what you see in living primates. So I would think that they're pretty, if we saw them today, we would think that they were pretty smart, pretty sophisticated, not at the level of humans, but certainly at the level of the smartest animals, or maybe a little bit above what you see in the smartest animals today.
Unfortunately, just this second, we've been informed that time's up. So unfortunately, we don't have time for more questions, but thank you. Thank you very much for visiting us and for having a chat with us. And thank you all for coming.
And thank you again for having me. I've really enjoyed this whole experience. Thank you very much.
Excellent. Thank you very much.